In this video, I am going to explain you all about the current status of Perseverance Mars rover. Currently, the Perseverance Mars rover is in Jezero Crater Delta, a well-preserved ancient river delta on Mars. In this picture, you can see that new research suggests that sedimentary rocks made of compacted mud or clay, like those found in the Jezero Crater Delta, are most likely to contain microbial foils. NASA's Perseverance Mars rover is busy at work exploring a Jezero crater. From orbit, this crater shows all the promising signs of a place that was likely friendly to life in distant past, explains a JPL website dedicated to the mission. The rover's goal is to study the site in detail for its past conditions and seek the very signs of past life. Its mission is to identify and collect the most compelling rock core and soil samples, which a failure mission could retrieve and bring back to Earth for more detailed study, adds the website. Indeed, imagery being taken by the rover is first rate, but are we close to detecting the past life on the red planet? In this video, this Mars rover signs of ancient life on Mars could be preserved in a layered rocks like those shown in these illustrations of NASA's Perseverance rover in Jezero Crater. Compelling evidence. The best case scenario for Perseverance finding compelling evidence of past life is the identification of biomedicated structures that can be observed with cameras, said Steve Ruff, a leading planetary geologist at Arizona State University in Tempe, Arizona. Ruff said that features like stromatolites, which occur at scales of millimeters to meters in size, are candidates. They form in standing water where microbial mats are mineralized, building up layers of biology and geology that can be preserved for billions of years, like found in ancient rocks on Earth. Ruff told Inside Out of Space. It's a huge win if something like that were found by Perseverance and then sampled. This would be a huge win for the mission. Ruff said that the sample would still need to be subjected to a battery of measurements in labs on Earth to really prove the microbes played a role. In terms of the material rocketed back to our planet, the risk to Earth is nil. Ruff said that the bugs that contributed to a stromatolite would have been dead for billions of years since the time there was a lake in Jezero, which is when such structures could have formed. Long dead microbes from Mars, at best, are now just degraded organic matter. Probably the equivalent of tar like compounds, so zero risk of infecting Earth. And this scientific triumph is still in work. Mars sample return mission was envisioned to go after a scenario like this, said Ruff. Finding evidence of long dead Martian microbes in samples returned to Earth, he said. And the bottom line, this scenario would be a scientific triumph and change our understanding about the potential for the life beyond Earth. A second data point would be confirmed. Longside mission. In this picture, you can see this. To support a campaign to return samples from Mars, multiple robots team up to ferry to Earth, select samples that are now being gathered by NASA's Perseverance Mars rover. This long sought mission is like pressing ahead on the agency's long sought vision of rocketing back to Earth piece of Mars. A Mars Sample Return (MSR) campaign is now being orchestrated by NASA and the European Space Agency, a multi spacecraft enterprise. This fast paced multi billion dollar endeavor is dedicated to hauling back planetary particles from the red planet to our world in the early 2030s. Christopher Kerr, an assistant professor with the Georgia Institute of Technology's School of Earth and Atmospheric Sciences, once worked on Mars sample return at NASA's Jet Propulsion Laboratory in the summer of 1999 to 2000. He says that my first reaction after reading a stack of slide presentations was, "You have got to be kidding this. It's so complicated," said Carr. It turns out completely like a complexity was and is highly driven by the requirement to have a low probability of releasing even a very small particle of mass material into Earth's biosphere. Carr added that even back then, the technology existed to provide the simultaneous protection of precious samples and protection against release of mass particles using the right series of isolators with differential pressures. And this is the kind of approach used, for example, in pharmaceutical manufacturing. It is not cheap and will require a specialized facility and specific work practices, Carr said. This planetary protection burden he reviews he views reasonable for legal, ethical, and moral reasons until we learn more about the risk. He advises ultimately Carr suspects such extreme measures will be unnecessary, in part because the surface of Mars today is uninhabitable to life as we know it. To date, we know that no overlap between conditions required for replication and conditions present on the surface of Mars. And this uncontrolled mass equipment, in contrast, continues. There is a large overlap in the temperatures and pressure in the surface of Mars and the range of inhabited environments on Earth. Carr said that Earth also continues to receive Mars metamorphic like a meteoritic material, although most of this arrives in the form of small particles that have been in space long enough to be sterilized. Thank you for listening to this video. I would like to share more interesting topics in upcoming days. Stay tuned. Until then, it's bye from Kamlesh. Thank you.